Did they enable or disable something?
No, everything is good.
Yeah,
Just
cool.
show us something on your screen.
Cool, I can start actually. Yeah.
You need to share the screen
on the Teams as well.
Stop sharing.
On Teams.
Yeah,
Okay,
yeah,
okay,
on
okay.
Teams.
1 second.
Probably maybe you're already sharing just in another screen. I think it's your desktop.
No, it's correct.
Yeah, yeah.
My name is Vadim. If you don't know, I'm a team member of Golang, and my today's talk is inspired by a talk of Donia Childuch called TinyGo, getting the upper hand that I heard at gophercon conference in Berlin this year. And Vasily is a big one, asked me, and another Vasily is a little one, to tell you what interesting we learned at that conference. Therefore, today I would like to tell you about basics of TinyGo, and then Vasily will continue with memory management of Go. And I should note that I'm going to speak from the position of newbie that heard about TinyGo for the first time, but not from the position of an expert in microcontrollers. So here are some photos from the conference and from the eastern side of Berlin, just to show you the atmosphere. But don't envy me, please, because you haven't seen this yet. This is the pinkest hotel in the world, and we had to stay. We had to stay there for 2 days. Thanks, Nguna.
Best hotel.
Yeah. Well, as the saying goes, what happens in Vegas stays in Vegas. Let's leave this topic.
Hoodie fits the environment. Your hoodie color.
Yeah. That's right. As I said, one of the few talks that was really memorable was a talk about monitoring a hen house using TinyGo. Literally, the talk description sounds like with any microcontroller and a few materials, you will have enough horsepower to build your monitoring system and pamper your chickens. So this will definitely come in handy. That's what I saw at that moment. I just couldn't leave these lovely chickens unattended. And here is a short brief of Donia's talk. She wanted to monitor the temperature and humidity inside her hen house. She took an Arduino Nano IoT board, connected some sensors to it, and then she wrote about 20 lines of code in Golang that take sensors data, send it over Wi-Fi somewhere to Prometheus and Grafana, ensure Kubernetes cluster on some interval. And now her chickens are happy. Cool story. And I'm really grateful to Donia for her presentation because she inspired me. So why I got interested in this topic? Why do you think a typical programmer does to relax and maybe to take some rest when he comes home from work, where he spent probably the whole day sitting in front of the computer and writing code? What do you think?
Sitting in front of computer, something else.
Yeah, that's right. He writes code for fun. And I'm not an exception to this, but sometimes it gets boring. That's why it seems to me the idea to make some device that you can touch and you can make it to do something useful is what I need. And this got me interested. Moreover, we're talking about programming microcontrollers in Golang, and that means you don't need to dive into hardcore C code. Just slash it together and deploy. It's what we love. Okay, what is TinyGo actually? TinyGo is a compiler for the Go programming language, but for smaller kinds of systems like microcontrollers, WebAssembly, and other devices with very limited resources. TinyGo has support 21 different boards and devices such as Arduino, Microbit, Raspberry Pi, and even Nintendo Switch. But there is a difference between TinyGo and the Go compiler. Let's take a closer look to TinyGo compiler architecture. Compared to the Go compiler, TinyGo has a huge level of optimizations that it is using with LLVM. Like most compilers, TinyGo is a compiler built in as a pipeline of transformations that each translate an input to a simpler output, which also called lowering. However, most of these parts are not not in the TinyGo itself. The front end is mostly implemented by external Go libraries, and most optimizations and code generation is implemented by LLVM, which is just a collection of modular and reusable compilers and libraries. For example, Go does a lot of initialization at runtime, which is really bad for code size. And this includes all global variables. They are all initialized at runtime, not at compile time like C. So TinyGo interprets these functions at compile time as far as it is able to. And there are also some TinyGo specific optimizations like escape analysis and string to array of bytes optimizations. And then standard LLVM optimizations are applied to it as well. And finally, the resulting machine code is emitted by LLVM to an object file. And this is just a compiler. TinyGo can also automatically link the file and flash it to a device if needed. Let's take a look at a simple application with a basic hello world. If you build it with Go, just a println hello world, the size of the binary will be 1.8 megabyte. And if you build it with TinyGo, it's going to be about 29 kilobytes. So you can see that the Go binary is much more larger, which make a huge difference in for the embedded world. And at the same time, TinyGo spends much more time compiling such a program, almost 3 seconds versus a half second for the Go compiler, 6 times difference. But it seems to be worth it. The size of binary is really impressive. But what should we prefer Go on embedded systems? Why not to use C or C++ that are what almost everybody uses in the industry? There are some good reasons to use something other than the status quo, which is C. One reason I'd say is ease of programming. And this means all the advantages of the Go language, including a strong standard library, a bunch of third-party packages, portability, and all this stuff. The second point is security. More than 2/3 of all security vulnerabilities in C are memory safety issues like buffer overflows. And any modern language prevents this, including Go. So just switching to another language has a huge impact on security and safety. And this is becoming more and more important now with lots of devices connected to the internet and Internet of Things. And another reason is concurrency, and this is where Go really shines. Most embedded systems are a single core, and they are very much concurrent. There are many inputs, many outputs, and lots of things running concurrently. That's why most bigger projects use what's called real-time operating systems, or RTOS. And this is more like a library than an operating system, actually. And they provide lightweight tasks. Sorry. They provide lightweight tasks, logs, channels, to communicate between them. And such operating systems also provide memory management, hardware abstraction layer, and sometimes a network stack. And all of this is already provided by the Go runtime or its standard library. When I decided to try out the case told by Donia, I realized, to my regret, that I don't even have a hen house. But I work for the telco and IoT company, and I could implement something more challenging and funny. And then I remembered that for Eagle Eye agent development and testing, we often need some dummy fake modem because real modems behave unstable and you can't rely on them for tests. And for those who maybe don't know what is the Eagle Eye agent does, in 2 words, this tool runs various tests by executing IT commands on the modem. And of course, we already have had a software tool for such a business, but imagine what if I took the task of creating a mock-up of modem literally. So to hell with the chickens. Especially for you, I went to the past in a time machine and got something. Let me show you. Pardon? Yeah. This is the dial-up modem Zixel Omni 56K. This is a quite common software modem. I stole it from Russians. So look here, all the labels are in Russian. Yeah, and maybe now I need to avoid the dark streets. I removed the original modem board and installed the Arduino in its place. This device is literally a fake modem. It pretends to be a modem and can respond to some limited set of IT commands, which enables the Eagle Eye agent to be run without a real modem. For example, it can pretend to be a quick tail modem and ping Google even without not being connected to the internet. Yes, and this is a small extension for debugging. Let me show you. Yeah. When I was reading the IT command parser, I faced with an issue with some unexpected inputs that I couldn't catch. And of course, I know that for such cases, smart people invented debugger a long time ago, and even my grandfather used it. But I haven't managed to connect the debugger. And if I understand correctly, debugging with GDB requires special hardware support. And there are some controllers with a built-in debug probe, but unfortunately, the Arduino is not one of them. There are some software GDB stub libraries which can give you most of the capability of the hardware debugger via the serial interface, but all I could find are libraries for C. But I didn't get upset. We still have our old friend, the println. And the catch here is that the only I/O channel we have is a serial port. If we write there, it will spoil the process of communication between agent and our pseudo modem. And what to do? I thank myself for keeping all the junk. I found this in an unpacked Nokia 5110 LCD display among all my stuff. Why wouldn't I use it for login? Okay, let's connect everything to the computer and try to start the agent. First we hook up the display to the Arduino. Here I have a special bus for it. Yeah, just a second. My gosh. I hope it doesn't fall apart. it would be so silly. Yeah. Now connect the USB. You should make sure to do it the right side. And yes, this one. Yes, the LED lights up. This is a good sign. You should also, 1 second. Something wrong.
Because you're not paying.
Hmm? Yeah, you also should see one logo here. That's my boss. Yeah, sorry for that. Now we need to find out the name of the corresponding device. On Linux, this is actually usually def tty ema 0, but on macOS, the device name may change. And we need to discover how macOS system has named it. Okay, let's switch to the IDE. So, to find it out, you should run the command like ls def grep usb. Yeah, here it is. That is it. And yeah, okay, let's check the agents config. Everything's correct. Yes. Look, no cheating. We use subhead as a driver for Raspberry Pi head. We use Pixel 25 driver as a modem driver, and we set the USB port to our Arduino. And here is a very simplified pipeline. It should initialize the probe in the modem with some port information, with some information about SIM card, perform this attachment, and finally the attachment. And yeah, let's try to start it without the modem first, so that you can see that everything is failed. No. Yes, it failed as expected. Now we connect the modem again. Start the agent. Yeah, look, it works now. It really thinks it has a modem. Of course, it's not a real sound, but an artificial one, and pipeline completed successfully now. Returning back to our presentation. Yeah, I tried to make sound we heard just a little bit similar, just for fun. But in fact, modems encode their signals in this way, trying to find a common language and determine the weaknesses of telephone channel originally meant for human speech. And here is a spectrogram of the handshake audio describing everything that happens at every stage of communication between two modems. By the way, this may surprise someone, but dial-up modems are still on sale and they are pretty expensive. I don't know why, but there are probably places where there's still no other type of connection. I don't know. I know that some companies, in order to maintain the compatibility of their legacy software, use kind of special proxy devices that pretend to be a modem, but in fact they not use a telephone line, and instead they connect via Ethernet or Wi-Fi, and enables this software to work without authentication. Here's what it looks like inside. Here's the hardware that I used, just a few components, Arduino Mega, here's a buzzer, 2 LEDs, and Nokia LCD display. And here's a wiring diagram. Let's finally get to the fun part and figure out how to use TinyGo and create a firmware for such a device. TinyGo has support for both IntelliJ IDE and VS Code IDE. I prefer the first one. So let's take it, for example. Of course, first thing you need is Go, and I think there's no need to explain how to install it. Then you need to install the TinyGo plugin for Golang. It provides an easy way of creating a new project, runs TinyGo applications, and code inspections. You can find it in the JetBrains marketplace. After installing this plugin, you also should install TinyGo SDK and configure some options for your microcontroller. And you can do all this without leaving your IDE. When you change the target platform, the TinyGo plugin will prompt you with the default settings for things like CPU architecture, garbage collector, and scheduler. And I would recommend to leave everything as this because the defaults is usually the best option. But if you can't resist to not to change something, then do it smart. According to the documentation, TinyGo supports 3 types of garbage collectors. None, that means that do not use a memory manager at all. This will cause a link error at every place in the program that tries to allocate memory. And the primary use case for that is finding such locations. Next option is leaking. It only allocates memory and never frees it. This is the simplest allocator possible, and it uses very few resources while being very portable and flexible. But larger programs will likely need a real garbage collector. And the last one, what happened?
Back.
Yeah, back.
Yeah, cool. The last one is a simple conservative Mark III garbage collector. As for scheduler, there are also 3 options. This option disables scheduler support, which means that routines and channels are not available, and it can be used to reduce firmware size and to reduce memory consumption if routines and channels are not needed. The Asyncify scheduler is a scheduler for WebAssembly, and the preferred one is a tasks scheduler, which is much like a real-time operating system. For Arduino, the default scheduler is known because it has very limited resources, but it's still possible to use the tasks scheduler if you want concurrency. At least it's possible. And it's time to write our first program. When we say hello world in the world of microcontrollers, we usually mean blinking LEDs. As always, we start with package main. We import here only 2 packages. The time is standard Go package. It enables us to do the sleep function. But the machine package is what allows you to talk to your board. It gives you some machine-specific constants. All the pins and other stuffs are defined there. Then we define a pin our LED is connected to. In my case, this is digital pin number 53. Next, we configure the pin for output because we're going to apply power to it to turn the LED on. Then we enter the loop, which turns the pin off, waits a half second, turns it on, waits again, and this repeats. And if you don't add sleep, the LED will be on just for 1 CPU cycle, and you probably even will not see it. Let's also add some println statement to output some text to a serial port just to get know how to do that. To build and then flash our basic building program to Arduino, first you should plug your Arduino to your computer USB port, don't forget it. Then just run the command you see on the slide. Port is optional, usually you can just ignore it, and that's it, pretty easy. TinyGo will compile a program on your computer, write it on chip memory, and the built-in LED on the board should start to blink at that moment. And finally, we'll run it on the chip. In order to read data from a serial port, you can either use a plugin for Golang called serial port monitor, or use built one in the Arduino IDE. There is no dramatic difference between them. You also can use a standard screen utility, or alternatively, you can write your simple Golang application for reading from serial port. Let's make some noise. Yeah. Here we import buzzer package. It provides a very simplistic driver for a connected buzzer. Our buzzer is connected to pin number 11, so we define it here. Then we configure it for output and create a new buzzer device using the buzzer package. Then we define our song using a format called PWM, or pulse width modulation, which just means an array of frequencies and durations. And finally, we play it within the loop. It's actually the Star Trek intro. Never been much of a musician, sorry for that. Now comes the interesting stuff. This is the Nokia 5110 LCD. This display has a resolution of 84 rows and 48 columns, and you can control each pixel individually. Before diving into code samples, let's first take a look at its pinout, because for me it was quite difficult to figure out how to connect it. So the RST pin resets the display. CE, or chip enable pin, is used to select one of many connected devices sharing same SPI bus. DC, or data command pin, tells the display whether the data it's receiving is a command or displayable data. DIN is a serial data pin for SPI interface. CLK is a serial clock pin. VCC pin supplies power. Backlight pin controls the backlight of the display. To control its brightness, you can add a potentiometer or connect this pin to any PWM-capable Arduino pin. But I just connected it to the ground. And GND should be connected to the ground of our board. You just need to connect everything properly, and then driver will make it work, giving you a very simple interface to interact with the screen. I'm not actually sure that I connected everything correctly, but it works. I know that many versions of this LCD display don't come with any current limited resistor, but who cares? Just don't be like me and add some resistors. Yeah, someone help me and connect my MacBook to power. Doesn't run out of battery.
I never connected MacBooks, but I will try.
I intentionally hid some lines of code here for simplicity. This program starts by including three libraries: PCD 8544 package to hide away all the complexities. Continuously. PCD 8544 package to hide the complexities, and so that we can issue simple commands to control the display, and also Proggy and Tiny font are just for drawing fonts. Variety CD function is just a naive implementation of println, which prints line and shifted cursor. And next, we need to create an LCD object. The constructor of it takes 4 arguments, which specifies the SPI bus, and Arduino pins are connected to the display. and SPI and pins must be already configured. And with the last line, we finally print text to the screen. You can also draw any image you want. Using function setBuffer, you need to pass a bitmap image into it, converted to array of bytes, and you can use a simple online tool named image to CPP to do that for you. Okay, programming for microcontrollers using TinyGo in particular has a lot of differences from traditional programming. And as a true developer, I certainly didn't read the documentation when I was doing my project. Therefore, I faced with all possible issues like memory leaks related to both limited resources and lack of knowledge. Also, TinyGo is still non-production ready and contains a lot of bugs. Some parts of Go features are still a work in progress. So, for example, I even haven't managed to use standard strings and FMT package with Arduino. However, the product is developing quite fast, and it can already be used for many pet projects. So I collected some useful links, including the firmware code and other code samples. And you can scan this QR code to get them all. Yeah, the links are still here. Thank you, and I hope this information is enough to start and probably inspired some of you to do experiments.
Finally, program terminals. Really good job.
Like what?
We programmed the payment terminals. So basically, everything that you shown is like flashbacks from different.
You didn't use TinyGo, right?
We didn't use. We used pure C.
I have a question here. Basically, what did you suggest is your project was based on TinyGo, based on the Golang.
Yes.
And you were using Arduino, both like microprocessor version of the Mega and microcontroller version of the Una. Because I think Arduino only uses microcontrollers, but not microprocessors, if I remember correctly. And then for the microcontroller version, maybe it's better to start with what Arduino provides themselves, like based on they have their own this thingy based on the C.
Probably. I agree. I just wanted to try this TinyGo. Yeah.
My thought is like using Go might be really relevant when we speak about micro processors. The processors when you have like really an OS possible there, but if we speak about controllers, so
what's the difference actually?
What's the difference between microprocessors?
You mean processors like Raspberry Pi has?
Yeah.
No, Arduino has microcontroller.
The Una definitely, but
Mega too.
Okay.
But the idea is that Arduino is actually using their Mega Atmel cable.
Yes.
And now the microchip actually bought the Mega Atmel. All this the companies. This Atmel is a sub company of the microchip. So Atmega product is automatically going to the microchip. As far as I understand, the microcontroller different between the microprocessor. The microcontroller contains the CPU modem, which is actually the calculation block, and the memory combined in one which is say component. It doesn't. Oh, the microcontroller microprocessor doesn't contain the operating systems. It's more like the Raspberry is a huge computer. Actually, like this one.
Yeah,
of course, it has the Linux distribution.
In two words, you can't install an operating system to Arduino, and that's why TinyGo shines here, because it's a kind of a lightweight operating system. At least you have concurrency, routines, tasks. That's great. Looks cool.
How much time did the project took?
I didn't count. Maybe 2 weeks, something like that. Actually, I started this summer.
The thing is basically you order, then you wait. Yeah. And then you have 1 hour to spend today, and then you wait.
Like that, like that.
And then you have a little more spare time.
Okay, thanks, Vadim. Time
you.
flies. We still have one speaker, Vasilis, talk about memory management.
I have a question.
Yeah, sure.
Which part of TinyGo sucks? I mean, it couldn't be perfect because obviously, when we are talking about such a small amount of binary file, it comes for a price.
Yes, yes, yes. There are a lot of bugs still. It's not a production ready. So it's really annoying issues like when you try to use standard things like FMT package or strings, you can't do this with Arduino. Maybe with other microcontrollers you can, but not with Arduino. And if you are a newbie like me, you can't understand why it's not working. It's your problem or TinyGo. So that's the main thing I think.
Thank you, thank you.
Yep. I think let's go.
Okay, so hi everyone. As you have already heard, me, Vadim, and Dmitry went to a gophercon presentation.